Hello everyone. So today what we're going to be talking about is finding the principal amount using the compound interest formula. So in previous lessons what we've done is we've used this formula, okay, the compound interest formula. A is equal to P outside of 1 plus R all to the power of n. We've used that formula to calculate the final amount. What we're going to be doing today instead, okay, is using the same formula to solve different problems, rather, where we are instead finding the principal amount, the amount that we initially put in to our bank account, what we invest, or what we might take out in regards to a loan, basically our starting amount, okay? So let's get stuck into it. So here's my first question. Calculate the principal amount if the final amount is $12,000 and it is invested for 4 years at 10% per annum, compounded annually. Like what we've done in class, what I want you to do is I want you to break this question apart and try and find the important parts. This question is telling you to calculate the principal amount. Okay? You're going to be finding P in that formula. Okay? It tells you the final amount is $12,000. So you have a value for A. It is $12,000. Okay? It tells you, right, that you have an interest rate of 10% per annum. Okay, 10% per annum. And I want you to leave a bit of space just below this, just in case we have to make any adjustments to it. Okay? It also tells you that it's invested for 4 years. Okay? So your N so far is equal to 4 years. Okay, now let's go through this. The other important part that we need to consider before we move on, okay, is that it is compounded annually. So that means that once per year, at the end of every year, my money is pulled out, the interest is added, and then it's put back in for the next year. Okay? As a result of that only being compounded once per year, that means for the entire year I get my full interest rate. Okay? So I don't have to adjust my interest rate. But what I do have to do is I have to write my interest rate as a decimal. Okay? And to write that as a decimal, okay, I simply take 10 and divide it by 100 to give me 0.1. Also, as it's compounded annually, that means it's compounded once per year, so therefore it's compounded 4 times in 4 years. Okay, so my n will equal 4. Okay, so let's do some substitution into the formula. We're going to use A equals P1 plus R to the n. Now we know we're going to use the compound interest formula because it says compounded annually. So I'm just going to substitute all of my values that I've just found into this formula. I end up with 12,000 is equal to P, which we don't know, okay, multiplied by, because remember there's a little time sign in there, 1 plus 0.1 all to the power of 4. Okay? Now what I would suggest you do is tidy up your brackets before you do anything, okay? Tidy it up before you move on. So I end up with 12,000 is equal to P times 1.1 all to the power of 4, okay? 1 plus 0.1 will just give you 1.1, okay? So next up, you might be asking yourself, where do we go from here? What am I going to do? I'll just move this up so you can see what's going on, okay? We're solving an equation here. We know this because we have an equal sign, which means to solve this equation and find P, our initial amount that we invested, okay, we need to get it by itself, which means I need to do something to this 1.1 to the power of 4 to get rid of it, okay, just to have P by itself. Notice that in between the P and the 1.1 to the power of 4 is a time sign, this little thing here. Okay, remember when we're solving equations, we do the opposite sign, which means the opposite of times is divide. Remember, I will write it as a fraction, and we do the same number. So I divide by 1.14 instead. Okay, and because we want to keep our equations balanced, okay, what I do to one side, I must also do to the other. So I'm going to divide 12,000 by 1.1 to the power of 4. Okay, now let's just take a look at this for a moment. I have 1.1 to the power of 4 divided by 1.1 to the power of 4. They are going to cancel, and on the right hand side, it is going to leave me with just P by itself, which is what we wanted. And then what we can do is on the left hand side, we can plug this into a calculator and figure out what number that we're going to get. And the number that we get is 8196.1614, and the decimal continues on for a little while. Okay? But remember, what we're talking about here, okay, is money. So we need to make sure that we correctly format our answer to make sure that we are talking about currency. Technically, we've just found our principal. 8,196.1614 would be what we would put into the bank account, okay, to get the final amount after this period of time. Okay? So what I'm going to do is I'm going to flip the equation to give me P is equal to, okay, remember with money we need to ensure that we have a dollar sign. Our number remains the same, 8196 point. Now, we need to do some rounding here. So I look, because money is 2 decimal places, I draw a line after 2 decimal places. I decide the number after the 6 is going to cause me to either keep the 6 the same or round it up. So because it is 1, it's below 5, okay, so the 6 will stay the same. So I end up with 1/6 as my answer. Now to ensure that we're being correct, I need to write 2DP, okay, just to ensure that that is all correct. I have rounded to 2 decimal places. I'm telling my marker that I have rounded to 2 decimal places. And that's how we answer the first one. Okay, so let's do another example. Okay, so here's our second example. Our second example says, calculate the principal amount if the final amount is $8,000 at 4% per annum for 6 years, compounded biannually. Okay, so let's have a look at how we would break this question down. It is telling us that we have to calculate the principal amount. Okay, so we're going to find P in our question. Alright, furthermore, okay, it tells you what the final amount is, $8,000. Okay, so you know that A is going to equal $8,000. I want you to have a look at this question though. There is an extra little bit in here that you may not have seen before. It says compounded biannually. Now when I talk about biannually, this means that it is compounded twice per year. Okay, so every 6 months. Okay, that is what biannually means. And that is going to affect the rest of this question. So I always try to look at compounded biannually, or how often it's compounded, before I look at my interest rates and my time periods, my number of compounding periods. Okay, so let's look at my interest rate next. Okay, it is equal to 4% per annum. So that means that for the entire year, we will receive 4%, okay, as our interest rate. However, this is compounded twice per year, okay? Because this is compounded twice per year, okay, for 6 months, it's only in there for half of a year before it's compounded the first time, which means that for the first half of the year, we only receive 2%, okay? We receive half of this interest rate, okay? So what we do is we divide our interest rate by 2 to account for how often it's compounded. So 4% divided by 2 gives us 2%, right, for the biannual period. So you could just write per 6 months. Okay, I'll just write a line there so we can see what we're doing. Okay, now, like I always say, we need to write this as a decimal. So this is equal to 0.02. Okay, as a decimal, we've adjusted for the compounding biannually, which means now that we look at the time period, so n is not necessarily going to be 6. Okay, so it's in there for 6 years, but it is compounded twice per year. Okay, so if it's compounded twice per year for 6 years, we multiply the 6 by 2 to give us 12 times for the number of compounding periods. Okay, so you'll notice here, I might just highlight this to you, that if we divide by 2 for the interest rate, we do the opposite and we multiply by 2 for the number of compounding periods. Okay, we follow that same pattern all the time. What we do to one, we do the opposite to the other. Okay, so let's have a look at our formula. Okay, I have A is equal to P outside of 1 plus R to the n. I always start off with this formula, always. Okay, I know that I'm using this formula, the compound interest formula, because it says compounded. Okay, I won't use simple interest formula. We won't get the correct answer. Okay, I then sub everything in. My A is equal to 8,000, which is equal to P times 1 plus my interest rate as a decimal, plus 0.02, all to the power of my number of compounding periods, which we know is 12. Okay? Now, we must do this. A common mistake that I see students do is they don't spend the time to adjust what their interest rate will be and what their number of compounding periods will be, and you will get your answer wrong. So you need to make sure that you adjust before you sub everything in. Okay? Let's do a little bit of tidying up. I end up with 8,000 is equal to P multiplied by 1.02, just 1 plus 0.02 gives me 1.02, all to the power of 12. Just like last time, I want to get P by itself to find the principal. So I look in between P and my number, 1.02 to the power of 12, there is a time sign. So we do the opposite, and we divide by 1.02, all to the power of 12. Okay, what I do to one side, I do to the other. 1.02 to the power of 12. Okay, because I have 1.02 to the power of 12 divided by itself, they will cancel and leave me with just my principal amount, okay, which is equal to this number here. Alright, now with this number here, I don't think I've given myself enough space to actually write out my decimal, so I'm going to write P more so over here. Let's move this up a bit so you can see what I'm still doing. Okay, so when I put this into the calculator, this number here on the left hand side, I end up with 6,307.9454 ... and it continues on. I'm going to put the dollar sign there early. Remember, we're talking about money though, so we need to ensure that we have two decimal places. So I go to my second decimal place and I place a line immediately after it. And I look. After that line, the number is 5. Okay? Because it is 5, we are going to round up for our second decimal place. Okay? If it's 5 or higher, we round up. If it's below 5, then we keep the decimal point the same. Okay? So this number here will become a 5. 4 rounds up to 5. Okay? So my principal amount, I'm going to flip the equation, okay, will become 6,307.95 to 2 decimal places. And that is your answer for that second example. Okay? So let's do another one, okay? And we'll keep working through this just so we can understand exactly what we're doing. Okay, so let's look at our third and final example for this video, and we're going to go through just like we have before, and we are going to highlight the important parts and find out what the question is actually asking us. Okay, so calculate the principal amount invested if the final amount is $24,440 at 14.8% interest per annum for 2¼ years, where it is compounded quarterly. Okay, so the question tells us we're calculating the principal amount. Okay, so we're going to find P. Okay, it tells us the final amount is $24,440. It tells us that our interest rate is 14.8% per annum, and we are told it's in there for 2¼ years, and it is compounded quarterly. Okay, right? So we know that it's compounded quarterly. Well, how often is it compounded quarterly? You think about a year, okay, and we divide that into quarters and put that into months. Okay, every 3 months would give us a quarter of a year. Okay, so if it's compounded quarterly, it means every 3 months. Okay, so let's move on. Let's try and figure out all of our values that we're going to substitute in, right? Okay, we know that our final amount won't change. We're told that it's $24,440. Okay, we are guaranteed that. So our next step is to look at the interest rate. Our interest rate is equal to 14.8% per annum. Okay? However, that's the interest rate for the entire year. We know that our question says that it's compounded quarterly, so that means every 3 months it is compounded. Okay? So we need to think about this interest rate for the entire year only being applied for a quarter of it. So we take the interest rate for the year, and what we're going to do to find out our interest rate for a quarter is we are going to take this number and we are going to divide by 4, okay, which will give us 3.7% per quarter. I'm just going to write per quarter here. Okay, right? Now, we've adjusted our interest rate to account for our compounding period. Okay, now we can write it as a decimal. Okay, writing 3.7% as a decimal will give us 0.037 as a decimal. All we do to get from here to here is we divide by 100. Okay, you can do that on a calculator if you need. I'll move this up so you can see what we're doing. Okay, now our N, our number of compounding periods. The question tells us that it's in there for 2¼ years. So 2¼ years. However, okay, we need to think about how many compounding periods we are going to have. Each one of these years is having 4 compounding periods because it's compounded 4 times within a year. So that means for the first year it's compounded 4 times. For the second year it's compounded another 4 times. And then you have an extra 1/4 of a year, which means that it's compounded 9 times in total. Okay? So your number of compounding periods that you have for that total investment is 9. Okay? So let's have a look about how we would go in terms of calculating this question. Okay? It's very similar. In fact, if you want to pause the video here, what you can do is you can attempt to work out this question yourself. Okay? And we'll go through it. Okay? So we're going to be using the compound interest formula. A equals P outside of 1 plus R to the N. And what we're going to do, okay, is substitute everything in. So our amount is 24,440. 24,440, which is equal to P, which we don't know, that's what we're trying to find, right? Multiplied by 1 plus our interest rate, which is 0.037, all to the power of 9. Okay, I ran out of room on my paper. Normally the 9 would be just a little bit more over. Okay, so now what we're going to do is we're going to be doing a little bit of tidying up of inside that bracket. So we end up with 24,440 because that has not changed. P multiplied by 1.037 to the power of 9. Now I'm sure by this stage you understand what we're doing for each step. Okay, we need to get P by itself, which means we need to get rid of this. Okay, so in between the P and the number is a time sign, so we do the opposite. We divide, okay, by 1.037 all to the power of 9. And what we do to one side, we do to the other. 1.037 to the power of 9, okay. We have 1.037 to the power of 9 divided by itself, okay. And that's our whole goal, was to get P by itself. I might just rewrite this out over here, which is equal to P, alright. Divided by, with P is equal to this number here, okay? So what we end up coming out with is this number, okay? If you enter this number into your calculator, you end up with $17,623.509 ... It continues on for quite some time, okay? Right? We're going to whack a dollar sign in front of that because we are talking about currency. And remember, when we talk about currency, we need to make sure that we round to 2 decimal places. So after the second decimal place, okay, we draw a line, and we look. Okay, 9 is greater than 5, so we are going to round up. Just that 1 decimal place. Okay, so our principal, our final amount, okay, our initial amount that we put in, our principal is equal to $17,623.51 to 2 decimal places, and that's your final answer. Okay, I hope this helps you out. Okay, go away, practice a little bit, okay, and you'll become masters of it. Okay, thank you very much.